3 feet 6 inches tall as a fully grown adult. That's it. That's your height. Forever. Not some medical condition, not malnutrition, just your species' normal size. The grass in Flores reaches your chest. A fallen log could be shoulder height. And that Komodo dragon sunbathing 20 feet away? Its head is bigger than your entire torso. This was reality for Homo floresiensis. And honestly, the whole hobbit nickname really undersells how completely screwed they were. So, if these stories help you relax or whatever, hit like or subscribe. Also curious where everyone's at. Comment your city and time. Reading through last video's comments and seeing Miami, Manchester and Melbourne all in there, the internet's weird, right? See, we love the Tolkien comparison because it makes them sound whimsical and adventurous, but Tolkien's hobbits were 4 feet tall on average. These guys, 3 feet 6, the tallest one ever found, and we're talking the absolute maximum here, was 3 feet 7 inches. Most were shorter. One skeleton, LB1, stood 3 feet 6 inches and weighed 55 pounds. For reference, that's less than your average border collie. An adult human you could literally throw over your shoulder and jog away with. Their brain was 400 cubic centimeters. Yours is around 1300. Theirs was smaller than a chimp's brain, closer to what we see in Australopithecus from 3 million years ago. By every metric we use to measure human capability, they shouldn't have been able to tie their shoes, let alone survive on an island full of monsters for 900,000 years. Yet there they were, making sophisticated stone tools and hunting elephants. Now, Flores during the Pleistocene wasn't your typical tropical island. This place was running its own evolutionary experiment where everything was the wrong size. You had rats that weighed 3 pounds, storks that stood 6 feet tall, vultures we haven't even properly classified yet, and ruling over all of it, the Komodo dragon, which back then was exactly as terrifying as it is now, except there were more of them, and Homo floresiensis was basically snack-sized. Let's talk specifics about these dragons because the size difference is genuinely absurd. Adult Komodos reach 10 feet long and 200 pounds. From a Homo floresiensis perspective, that's a creature 3 times your height and 4 times your weight that can run 13 miles per hour. Has 60 razor-sharp teeth that replace themselves every 40 days and carries venom that causes paralysis and prevents blood clotting. Modern humans with guns still die from Komodo attacks about 20% of the time. These people had pointy rocks. The dragons hunted using ambush tactics, hiding in grass that would barely reach their bellies but would be over the head of an adult Homo floresiensis. They wait near water sources because everything needs to drink eventually. When prey gets close, they explode from cover, and at 13 miles per hour versus Homo floresiensis's weird high-stepping hobble caused by their flat feet and odd leg proportions, it's not much of a chase. But somehow the dragons weren't even the worst thing they dealt with. Leptoptilos robustus, a marabou stork, stood 180 centimeters tall. For the Americans, that's 5 feet 11 inches. This bird was literally looking down at adult Homo floresiensis. Its wingspan stretched 12 feet. Unlike modern marabou storks that mostly scavenge, this one actively hunted on land. The fossil record shows they lived in the exact same caves, competed for the exact same food sources. A modern marabou stork can swallow prey up to about 2 pounds whole. Scale that up proportionally, and a juvenile Homo floresiensis, probably weighing 10 to 15 pounds, is absolutely on the menu. The adults at 55 pounds might be safe from being swallowed, but those beaks were designed for tearing flesh, not just swallowing. And when you're 3 feet tall fighting a 6-foot bird for a dead rat, you're probably losing that fight. The snakes add another layer of nope to this whole situation. Flores had and still has reticulated pythons, which are the longest snakes in the world. The ones on Flores reach 20 feet. 20 feet of snake versus 3.5 feet of human. These pythons lived in the same caves Homo floresiensis used for shelter. One python found recently in a Flores cave measured 6.1 meters. That snake could have swallowed an adult Homo floresiensis without much difficulty. Then you've got your standard tropical nightmare package, spitting cobras that can blind you from 8 feet away, Russell's vipers with hemotoxic venom, white-lipped pit vipers, and because why not, the island also has 19 species of venomous spiders, venomous scorpions, and the Asian giant hornet, which kills full-sized modern humans regularly. Everything on this island was specifically designed to murder you, and you're the size of a kindergartner. But here's what makes no sense whatsoever. Despite being bite-sized prey surrounded by predators, despite having brains that shouldn't support complex thought, Homo floresiensis dominated parts of this island for longer than our entire species has existed. They hunted stegodon, these dwarf elephants that still weighed over 1,000 pounds. That's like a modern 5-year-old successfully hunting a rhinoceros with stone tools. The cut marks on stegodon bones tell the story. These weren't scavenged kills. The placement and depth of the cuts show systematic butchering, probably of animals they killed themselves. They targeted juveniles mostly, which still weighed hundreds of pounds. A juvenile stegodon versus a group of Homo floresiensis would have been like a bunch of third graders trying to take down a grizzly bear. The physics alone seem impossible. Stone tools tell us even more. Over 10,000 artifacts from Liangbua cave alone. Points, perforators, blades, microblades. Some of these microblades were probably hafted onto wooden shafts to create composite tools. This isn't just banging rocks together. This is understanding materials, science, engineering, and physics, with a brain the size of an orange. The tool tradition stretches back hundreds of thousands of years with barely any changes. At Matamenga, 50 miles away, they found tools from 840,000 years ago made the exact same way. This technological continuity across nearly 1 million years is actually insane. In that same time span, other human species went from simple choppers to cave paintings. Homo floresiensis found something that worked and just kept doing it. Fire use is confirmed from charred bones and fire-cracked rocks. Controlling fire requires forward planning, delayed gratification, and abstract reasoning. You need to gather fuel before you need it, maintain it constantly, understand cause and effect. According to our models of brain development, 400 cubic centimeters shouldn't be able to handle this, yet they did it routinely. The bones in Liangbua are mostly from juvenile animals. This isn't random. They were making calculated decisions about risk versus reward. Adult stegodon means more meat but also more danger. Juveniles are easier to kill, easier to carry, bones easier to break for marrow. This is cost-benefit analysis from a brain that shouldn't be capable of basic planning. And somehow, despite everything trying to kill them, despite being the smallest, weakest, most vulnerable humans to ever exist, they lasted 900,000 years. Modern humans have been around for 300,000. Neanderthals lasted about 400,000. Homo floresiensis nearly tripled that on an island where everything wanted to eat them. The physical adaptations are weird even by human evolution standards. Their feet were huge and flat, more like an Australopithecus than anything in the Homo genus. The foot was 196 millimeters long on a body that was 1,060 millimeters tall. Proportionally, that's like size 15 shoes on someone 5'6". These weren't just small humans, they were something genuinely different. Their shoulders were shrugged permanently forward due to shortened clavicles and a differently angled shoulder joint. The humeral torsion, the twist in the upper arm bone, was 120 degrees compared to our 145 to 165. This would have given them a completely different range of motion, a different way of throwing, swinging, climbing. They moved through their environment in ways we can barely reconstruct. The wrist bones are the smoking gun that this wasn't just a diseased modern human. The trapezoid bone in their wrist is pyramidal shaped like an ape's, not boot-shaped like ours. This is primitive anatomy from millions of years ago showing up in a species that survived until 50,000 years ago. It's like finding a modern car with a hand crank starter. It shouldn't exist, but it does. Brain organization might have been their secret weapon. Despite the tiny size, the Brodmann Area 10, associated with complex reasoning and planning, was proportionally the same size as ours. Maybe they achieved with efficient wiring what we achieve with bulk processing power. A supercomputer versus a mainframe, both getting the same job done through completely different approaches. The population size makes their survival even more improbable. Based on the island's resources and typical hunter-gatherer densities, there were probably never more than a few thousand Homo floresiensis alive at any time, maybe just a few hundred. Every death was a potential catastrophe. Every birth was crucial. They were perpetually on the edge of extinction for 900,000 years and somehow never fell off. Getting to Flores required crossing the Wallace Line, one of the most significant biogeographical barriers on Earth. This isn't some shallow strait you can island hop across. The Lombok Strait drops to depths of 1,300 feet even during ice ages. The currents are brutal. Modern boats struggle with it, yet somehow Homo floresiensis ancestors made it across around 1 million years ago without boats, because boats wouldn't be invented for another 950,000 years. The accidental raft theory is the only explanation that makes any sense, and it's completely insane. Volcanic eruption or earthquake hits the coast, chunk of land breaks off with vegetation and maybe some early humans clinging to it. Most of these floating death traps would have drifted into open ocean. But through pure stupid luck, one raft with maybe 20 terrified hominins washes up on Flores after days without fresh water. Congratulations, you've founded a new species. This founding population was probably less than 100 individuals, possibly less than 50. Every Homo floresiensis that ever lived descended from this tiny group of shipwreck survivors. The genetic bottleneck would have been extreme, inbreeding unavoidable, the founder effect running wild. Within a few thousand years, they weren't the same species that left the mainland. They were something new, shaped by the brutal mathematics of small population genetics. The first generation born on Flores would have been slightly smaller than their parents. Not dramatically, just a few percent, but generation after generation the island selected for smaller bodies. Less food required, easier to hide from predators, less energy needed for basic survival. The ones who stayed large died out. The small ones survived. Evolution in fast forward, observable within dozens of generations instead of thousands. Their teeth tell a weird story. The jaw shrank faster than the teeth, creating this bizarre dental arrangement where adult Homo floresiensis had teeth too big for their mouths. Eating would have been awkward at best. The third molars, wisdom teeth, often didn't have room to fully emerge. Some skulls showed dental crowding that would make an orthodontist weep. This is evolution caught in the middle of a transition, frozen at an awkward stage. Water procurement without modern containers was a daily life or death challenge. The crocodiles knew where the water sources were, so did the dragons. Every trip to drink was potentially fatal. They probably used folded leaves or hollow gourds, but carrying water when you're 3 feet tall with tiny hands is inefficient at best. Multiple dangerous trips just for basic hydration. The giant rats everyone mentions casually were Papagamys armandvillei, and they weighed about 3 pounds. For perspective, that's a rat the size of a chihuahua, with teeth designed for gnawing through hard materials. These weren't passive prey animals, they fought back. Hunting them meant close quarters combat with something that could inflict serious damage if it got a good bite in, and when you weigh 55 pounds, every injury is potentially fatal. Plant resources presented their own problems. Fruit trees that modern humans can reach from the ground would require climbing for Homo floresiensis, but their weird shoulder anatomy made climbing different from how we do it. The shrugged forward position, the reduced arm rotation. It all suggests they climbed more like chimps than modern humans, except they didn't have the grip strength or the proportionally long arms. Every climb was risky. The population dynamics are depressing when you think about them too hard. With maybe a few hundred individuals total, everyone was related to everyone. Your dating pool was your extended family. Genetic diversity was basically non-existent. Every epidemic could wipe out the entire species. They survived on the absolute knife edge of viability for longer than any other human species we know of. Social structure would have been completely different from larger human populations. You can't have outcasts when every person is essential for survival. Can't exile troublemakers when you need every able body for hunting and defense. Conflict resolution had to be immediate and effective because the group couldn't afford to split up. They were forced to get along by pure necessity. The knowledge transfer problem was severe. If the one person who knew how to make the best stone blades died before teaching others, that knowledge was gone forever. No writing, probably limited language with those tiny brains, just whatever could be demonstrated and remembered. Every elder who died took irreplaceable knowledge with them. The fact that their tool tradition stayed consistent for hundreds of thousands of years suggests incredibly strong cultural transmission despite these limitations. Night was absolute terror. You're 3 feet tall in a cave that might contain a 20-foot python. No night vision, no real weapons that work in darkness. Fire was the only thing between them and complete vulnerability. But maintaining fire requires constant fuel gathering, which means going out where the predators are. The logistics of simple survival were a nightmare of cascading challenges. Weather events that we'd consider minor inconveniences would have been catastrophic. A tropical storm with winds that might knock us down could literally carry away someone weighing 55 pounds. Flooding that we could wade through would be over their heads. Finding shelter strong enough to protect them, but small enough that predators couldn't follow, was a constant challenge. Disease management without medicine or even basic understanding of germs meant that every infection was potentially lethal. A cut that got infected, a broken bone that didn't set right, dental abscess, parasites. The typical Homo floresiensis probably lived with multiple chronic health issues that would have killed them if any got slightly worse. Their skeletons show signs of healed injuries that must have been agonizing. Pregnancy and childbirth at that size would have been extraordinarily dangerous. The mothers were the size of modern 6-year-olds. The babies were probably under 2 pounds at birth, possibly closer to 1 pound, completely helpless for far longer than modern human infants. The caloric requirements of pregnancy and nursing when you're already barely surviving on an island with limited resources meant that every successful birth was a minor miracle. Childcare was a group effort by necessity. A mother that size couldn't protect a baby from much of anything while also gathering food. The entire group had to be involved in child rearing. The anthropological term is alloparenting, but for Homo floresiensis, it wasn't a cultural choice. It was the only way babies survived to adulthood. The volcanic activity on Flores added another layer of constant danger. The island has been volcanically active throughout human occupation. Lava flows, ash falls, pyroclastic flows, lahars. When you're 3 feet tall and can't run fast, a volcanic eruption isn't something you evacuate from, it's something you die in, yet somehow they survived multiple major eruptions over their time on Flores. Food storage would have been nearly impossible. No pottery, no preservation techniques we can detect. Living in a tropical climate where everything rots quickly, every meal had to be caught or gathered fresh. No saving for lean times, no building up reserves, just constant relentless food acquisition in an environment where you're competing with creatures much better adapted for predation. The lack of projectile weapons is significant. Every hunt had to be close quarters. You had to get within arm's reach of your prey, which meant your prey could reach you too. Hunting stegodon meant getting close enough to stab something that could crush you with one step. The bravery or desperation required is hard to fathom. Tool manufacturing with those weird hands and shoulders would have been different from how we do it. The grip was different, the leverage was different, the angle of strike was different. Modern experimental archaeologists trying to replicate their tools often fail because we're not built the same way. They had to develop techniques specific to their anatomy, another layer of specialized knowledge that had to be preserved across generations. The seasonal variations on Flores would have dramatically affected resource availability. Dry season meant water sources drying up, concentrating predators and prey at the remaining water. Wet season meant flooding, increased disease, difficulty making fire. There was no good time of year, just different types of hardship cycling endlessly. Navigation on the island, when you're that small, changes everything. A hill that's a mild incline for us is a mountain for them. A stream that's a hop across for us is a dangerous river crossing. They experienced Flores at a completely different scale, with different barriers and passages than taller humans would perceive. Their mental maps of the island would have been alien to us. The competition with other species for caves was constant. The good caves, dry and defensible, were also wanted by bears, pythons, and other creatures. Securing and holding a cave required constant vigilance. Leaving for a hunting trip might mean returning to find your home occupied by something that now considered you an intruder. Communication without complex language is still debated. Their brain size suggests limited linguistic capability, but their survival required coordination. They must have had some system, maybe gesture-based, maybe simple vocalizations that allowed them to work together. Hunt planning, danger warnings, tool-making instruction, all had to be communicated somehow. The evidence suggests they understood scheduling. Bones show hunting patterns that align with prey animal behavior. They knew when certain animals would be at specific locations. They worked around predator activity patterns. This temporal mapping required memory, planning, and pattern recognition that shouldn't have been possible with their brain size. Peter Brown was examining the wrist bones of LB1 in Sydney when he noticed they were completely wrong for a Homo sapiens. The trapezoid bone was pyramidal, like a chimp's. The scaphoid was oriented differently. These were ape wrist bones in a skeleton from 50,000 years ago. Not diseased human bones. Not deformed bones. Primitive bones that shouldn't exist in any member of genus Homo. That's when everyone realized this wasn't just a small human. The initial dating suggested 18,000 years old. If true, Homo floresiensis would have overlapped with modern humans for 30,000 years. They would have existed while we were painting caves in Europe, developing agriculture in the Middle East, spreading across the Americas. The idea that another human species survived that long broke every model of human evolution we had. The scientific fight turned nasty immediately. Tuku Jacob, Indonesia's senior paleoanthropologist, literally took the bones from the repository without permission, kept them for months. When he returned them, the pelvis was smashed, the skull was damaged from unauthorized casting attempts, some pieces were missing entirely. Bones that survived 900,000 years underground were destroyed by academic ego in a matter of months. The skeptics pushed hard for pathology. Microcephaly was the favourite explanation, a genetic condition causing small brains. But microcephalics don't have primitive wrist bones, they don't have Australopithecus-style feet, and you don't find 15 microcephalics in one cave spanning thousands of years. The pathology argument required ignoring basically all the anatomical evidence. Laron syndrome came next, a type of dwarfism, but Laron syndrome doesn't change your wrist bones to ape configuration, doesn't give you feet proportionally larger than any modern human, doesn't explain the tools going back 800,000 years. Each proposed pathology explained one feature while ignoring 20 others that didn't fit. Then came the teeth. The dental analysis showed a mix of primitive and derived features that didn't match any known human population, diseased or otherwise. The premolars had multiple roots, unusual in modern humans. The molars showed patterns last seen in Homo erectus. The wear patterns suggested a diet different from any modern human group. These weren't just small people, they were dentally distinct. The foot bones sealed it. The navicular bone, one of the foot bones near the ankle, lacked the configuration for a proper arch. Modern humans have arched feet for efficient walking. Homo floresiensis had flat feet like Australopithecus. This isn't a disease or a deformity. It's a completely different evolutionary path that diverged millions of years ago. The inner ear anatomy visible in CT scans showed something unexpected. The semicircular canals, which control balance, were oriented differently than in modern humans. This suggests they moved differently, balanced differently, maybe even perceived motion differently. Every new analysis revealed they were more alien, not less. The tools became evidence for intelligence rather than against it. At Mata Menga, tools from 700,000 years ago showed the same manufacturing techniques as those from 50,000 years ago. This technological continuity across that time span doesn't happen by accident. It requires teaching, learning, and cultural transmission across thousands of generations. The discovery of the 700,000-year-old fossils at Mata Menga changed the timeline completely. The jaw fragment was even smaller than LB1, adult teeth in a tiny jaw. Either Homo floresiensis was getting bigger over time, which makes no evolutionary sense, or there was size variation we haven't captured yet, or possibly multiple species, which opens whole new cans of worms. Brain organization rather than size became the focus. The convolutions visible in skull casts suggested reorganization compared to other Homo species. Brodmann area 10 was proportionally large. The frontal lobe showed unexpected development. Maybe intelligence isn't about cubic centimeters, but about neural density and organization. They were running different software on different hardware. The stone tool caches found in Liangbua weren't random accumulations. Specific tool types were stored in specific cave areas. Blanks for future knapping were kept separate from finished tools. Cores were stored differently than flakes. This is organization, planning, maybe even primitive economy. Someone was managing resources systematically. Fire evidence got more complex with analysis. The charred bones showed selective burning, mostly juvenile stegodon, specifically limb bones burned in patterns suggesting roasting rather than accidental fire exposure. The fire-cracked rocks were arranged, not scattered. They weren't just using fire, they were controlling it precisely for specific purposes. The lack of art or symbolic behaviour became its own mystery. Every other human species that made tools this sophisticated also made art. Cave paintings, jewellery, burial goods, something. But Homo floresiensis left nothing symbolic we can identify. Either they expressed themselves in ways that didn't preserve, or they had a fundamentally different cognitive architecture that didn't require symbolic expression. The hunting evidence got more impressive with analysis. Cut marks on stegodon bones showed systematic butchering. The angles suggested multiple individuals working simultaneously. The depth indicated stone tools sharp enough to cut through thick hide. The location of cuts showed anatomical knowledge, targeting specific muscle groups. This wasn't opportunistic scavenging, it was organised, efficient predation. Microscopic analysis of the stone tools revealed use wear patterns. Different tools showed different wear, suggesting specialized purposes. Some were clearly for cutting meat, others for scraping hides, some for working wood. They had a toolkit, not just tools. Each implement, designed for specific tasks, maintained and curated over time. The absence of human conflict evidence is striking. No embedded spear points in bones, no skulls with weapon trauma, no defensive injuries on arm bones. In 900,000 years, we find no evidence they fought each other. Either they were incredibly peaceful, or their population was so small that conflict was literally unaffordable. The revised dating to 50,000 years ago made the overlap with modern humans much shorter, maybe non-existent, but it also meant they survived everything nature threw at them for 900,000 years, then disappeared right when modern humans showed up. That timing is too convenient for coincidence. We were either the cause or the last straw. New geological analysis revealed more about their environment. Flores experienced sea level changes of hundreds of feet during their occupation. The island grew and shrank dramatically. Resources appeared and disappeared. Yet Homo floresiensis adapted to every change. Their flexibility is more impressive than their longevity. The sexual dimorphism question remains unresolved. We can't reliably identify males versus females in the fossil record. Either they had very little size difference between sexes, unusual for Homo species, or we're missing half the picture. This affects every population estimate and social structure model we try to build. Tooth development studies showed they matured differently than modern humans. The tooth eruption patterns suggest a childhood longer than chimps but shorter than ours. They were reaching adulthood faster than we do, necessary when your whole species is perpetually near extinction. But this also means less time for learning, making their cultural transmission even more impressive. The hand bones revealed unexpected dexterity. Despite the primitive wrist configuration, the finger bones showed muscle attachment points suggesting strong grip and fine motor control. They were making precision tools with hands that were theoretically unsuited for the task. Another example of evolution finding unexpected solutions. Isotope analysis of the bones revealed diet details. They were eating a varied diet, including plants, meat, and possibly freshwater shellfish. The strontium levels suggested they weren't travelling far from their home caves. They had small territories, maybe just a few square kilometres per group. Their entire world was incredibly small. The absence of DNA remains the biggest frustration. Every extraction attempt has failed. The tropical climate destroyed the genetic material completely. We can get DNA from Neanderthals in Europe from 300,000 years ago, but not from Homo floresiensis from 50,000 years ago. The secrets in their genes are probably lost forever. The wear patterns on their teeth suggest they were using them as tools, holding materials while working them with their hands. This is seen in other human species, but the wear on Homo floresiensis teeth is more extreme. When your whole body is a toolkit, even your teeth become implements. Recent discoveries keep pushing the timeline back. Stone tools from other sites on Flores date to 1 million years ago. Someone was making tools on Flores before Homo floresiensis evolved their distinctive features. Were these their ancestors? Another species entirely? The picture keeps getting more complicated, not less. The skull of LB1 showed something unexpected in recent analysis. Faint marks suggesting blood vessel patterns indicated brain cooling adaptations. Their small brain was running hot, metabolically expensive despite its size. This supports the idea of a densely packed, highly efficient neural structure rather than our bigger is better approach. The archaeological record at 50,000 years ago looks like someone flipped a switch. Stone tools change style abruptly. New animals appear in caves. Homo floresiensis vanishes completely. Not a gradual decline, not a slow fading. They're there, then they're not. 900,000 years of continuous existence ends in what looks like a single generation. Modern humans reached Flores around 50,000 years ago, maybe slightly earlier. They came with projectile weapons, dogs possibly, diseases definitely, and brains 3 times larger than Homo floresiensis. The timeline is too perfect for coincidence. The longest surviving human species meets the newest one and immediately goes extinct. The disease hypothesis makes ugly sense. Modern humans carried pathogens from mainland Asia, accumulated from contact with different populations, animals, environments. Homo floresiensis had been isolated on Flores for nearly 1 million years. Their immune systems would have been completely unprepared. Something as simple as influenza could have wiped them out in months. Consider the demographic mathematics. Maybe 1,000 Homo floresiensis total on the island. A mortality event that killed even 30% would have been catastrophic. They couldn't absorb those losses. No recovery possible. The survivors would have been below minimum viable population. Genetic meltdown would finish what disease started. The competition scenario is equally plausible. Modern humans were better hunters, objectively, throwing spears that could kill from 30 feet versus having to get within stabbing distance. Coordinated group hunting with sophisticated communication versus whatever limited language Homo floresiensis had. Every stegodon killed by modern humans was one Homo floresiensis wouldn't get. The caves tell the story. Layers with Homo floresiensis tools and bones, then suddenly layers with modern human artifacts. No overlap, no gradual transition. It's like Homo floresiensis vanished overnight and modern humans moved in the next morning. The replacement was total and probably rapid. Violence can't be ruled out. We have no evidence of interspecies conflict, but absence of evidence isn't evidence of absence. If modern humans actively hunted Homo floresiensis, would we even recognize it in the archaeological record? Small bones in a tropical climate disappear quickly. A genocide would leave little trace after 50,000 years. The psychological impact on modern humans who encountered them must have been intense. Here were beings that were almost human, but fundamentally different. Too similar to be dismissed as animals, too different to be recognized as equals. Did they try to communicate? Did they recognize them as distant relatives? Or did they see them as competitors to be eliminated? The lack of hybrid evidence is telling. No DNA, but also no intermediate skeletons, no bones showing mixed characteristics. Either the two species never interbred, couldn't interbreed, or any hybrids didn't survive. Complete reproductive isolation after 50,000 years of potential contact suggests something prevented mixing. The ecological cascade from their extinction would have been significant. Every rat they didn't hunt bred more. Every stegodon calf they didn't kill grew to adulthood. The plants they gathered grew unchecked. Their caves became available for other species. An entire ecological niche suddenly empty after 900,000 years. The weapons disparity was insurmountable. Modern humans had throwing spears, probably atlatls, possibly bows. Homo floresiensis had thrusting spears at best. In any direct conflict, the outcome was predetermined. It would have been like bringing a knife to a gunfight, except the knife is tiny and you're 3 feet tall. The communication barrier would have been absolute. Modern humans had full language, complex grammar, abstract concepts. Homo floresiensis, with their tiny brains, probably had limited vocalizations, maybe gesture-based communication. Negotiation was impossible. Cooperation unlikely. Misunderstanding guaranteed. Climate data shows no major environmental change at 50,000 years ago, no volcanic eruption, no dramatic sea level change. The environment that had supported Homo floresiensis for hundreds of thousands of years was still there. Only one variable changed. Modern humans arrived. The Rampasasa people of Flores, with their high frequency of short stature, seemed like possible descendants. The excitement was enormous. Maybe Homo floresiensis genes survived in the modern population, but genetic testing found nothing. The Rampasasa are fully modern humans with a growth hormone receptor gene mutation. The short stature is convergent evolution, not ancestry. The Abu Gogo legends are too specific for comfort. Small hairy people, long arms, potbellies, strange walking gait, mumbling speech that could mimic human words. The Nage people who tell these stories live 100 kilometers from Liangbua, but Homo floresiensis probably wasn't confined to one cave. The descriptions match the fossils too well. The stories say Ebu Gogo survived until the 1800s. Villages would leave food out to appease them. They'd steal crops, kidnap children, supposedly. The last ones were killed when villagers trapped them in a cave and burned them alive. That's 200 years ago, not 50,000, but oral traditions that old would be unprecedented. Australian Aboriginal stories accurately describe landscapes from 10,000 years ago, sea levels from the Ice Age, extinct megafauna. If those stories can survive 10,000 years, why not 50,000? The implications make archaeologists deeply uncomfortable. It suggests Homo floresiensis might have survived far longer than the fossils indicate. Recent searches for surviving populations find nothing. Every expedition into remote areas of Flores comes back empty. Every reported sighting turns out to be macaques or nothing at all. If Homo floresiensis survived past 50,000 years ago, they're gone now. The window for finding living specimens, if it ever existed, has closed. The technological knowledge lost with them is irreplaceable. They knew every edible plant on Flores, every water source, every seasonal variation, the behavior patterns of extinct animals, cave systems we haven't found. They had 900,000 years of accumulated wisdom about surviving on that island, and it's gone forever. The modern human toolkit from early Flores shows interesting patterns. Some tools look influenced by Homo floresiensis techniques, same raw materials, similar napping strategies, but with modern human modifications. Did they learn from Homo floresiensis before they went extinct? Did they watch them, copy them, then replace them? The megafauna extinction on Flores correlates with both events. Stegodon disappears, giant storks vanish, several rat species go extinct. Was this from Homo floresiensis disappearing and ecological balance shifting, or from modern human overhunting, or both? The timing makes it impossible to separate causes. The lack of clear burial sites remains puzzling. If Homo floresiensis had existed for 900,000 years, where are all the bodies? Even with poor preservation, we should find more. Did they have disposal practices that removed bodies from the archaeological record? Did they practice excarnation, water burial, something that left no trace? Modern Flores shows no genetic trace of Homo floresiensis in any species, not in the humans, not in the parasites that would have jumped between species, not in the gut bacteria that might have been shared. The separation was complete. They lived alongside modern humans potentially for centuries and left no biological trace in the modern ecosystem. The question of consciousness haunts the extinction story. Were they self-aware in the way we understand it? Did they have names for each other? Did they understand death was coming for their species? The last Homo floresiensis might have known they were the last, or they might have died thinking others survived elsewhere. The scientific impact continues to ripple. Every assumption about brain size and intelligence has been questioned. Every model of human migration needs revision. Every timeline has been adjusted. Homo floresiensis didn't just add data to our understanding. They revealed how little we actually understood. The indigenous stories about small people aren't unique to Flores. Similar tales exist across Indonesia, the Philippines, mainland Southeast Asia. Each island might have had its own endemic human species. We've found Homo floresiensis and Homo luzonensis. How many others existed? How many went extinct without leaving fossils we'll find? The survival strategies Homo floresiensis developed died with them. Techniques for hunting with primitive tools, methods for avoiding predators when you're half the size of your prey, ways to maintain fire in tropical humidity with limited resources, solutions to problems we don't even recognize as problems because we've never been that small. Their extinction marks a turning point. Before 50,000 years ago, multiple human species coexisted across the old world. After, only modern humans remained, with Neanderthals and Denisovans hanging on briefly in refugia. Homo floresiensis was part of the last generation of human diversity. Their loss marked the beginning of our species' lonely dominance. The moral weight is uncomfortable. If modern humans caused their extinction, either directly or indirectly, it was our first genocide of another human species, or at least the first we have clear evidence for. We eliminated a branch of humanity that had survived longer than we've existed. Success in evolution doesn't mean you're safe from extinction. It just means you haven't gone extinct yet. The bone theft in 2004 turned into an international incident. Teuku Jacob, basically the godfather of Indonesian paleoanthropology, just took the fossils. No permission, no paperwork, just showed up and removed them. His team made unauthorized casts that damaged the skull. They broke the pelvis trying to reconstruct it. Parts went missing and never came back. The Indonesian government had to get involved. The Australian team threatened to pull out entirely. It was absolute chaos. Why did Jacob risk his entire reputation? Because these bones proved him wrong about everything. He'd spent decades arguing that Indonesian fossils showed continuous evolution from Homo erectus to modern humans. Homo floresiensis destroyed that narrative. They were too primitive, too weird, too impossible. Rather than accept he was wrong, he tried to control the evidence. The damage report makes you want to scream. The left pelvis crushed, the skull scratched and chipped from bad casting material, several teeth missing, finger bones gone. These fossils survived 900,000 years underground, volcanic eruptions, earthquakes, tropical decay, only to be destroyed by human ego in 3 months. We lost irreplaceable data because someone couldn't admit they were wrong. The political fallout changed Indonesian archaeology forever. New laws about fossil access, international oversight requirements. The Liang Bua site became a flashpoint for indigenous rights versus scientific access. The local Manggarai people wanted control. The government wanted tourism money. Scientists wanted unrestricted access. Everyone had valid claims. Nobody had clear authority. Tourism exploded overnight. Flores went from unknown island to hobbit homeland. Hotels sprouted around Liang Bua. Tour guides who'd never heard of Homo floresiensis were suddenly experts. The cave that had been a quiet research site became a selfie spot. Every footstep potentially damaging unexcavated fossils. The discovery that put Flores on the scientific map might end up destroying the evidence. The DNA extraction failures keep mounting. 20 years of attempts, 0 success. The bones are there, we can see them, touch them, measure them, but we can't read their genetic code. Every new extraction technique fails the same way. The tropical climate destroyed the DNA so thoroughly that we might never recover it. We're locked out of their genome permanently. Without DNA, we can't answer the basic questions. Were they Homo erectus that shrank, a separate migration from Africa? Could they interbreed with modern humans? How diverse was their population? Every question leads back to genetics, and genetics leads back to nothing. It's like having a book where every page is blank, but the cover. The Denisovan discovery made Homo floresiensis seem less impossible, another human species we didn't know existed, found through a single finger bone. They interbred with modern humans, left DNA in living populations. If Denisovans could hide in the genetic record, what else is out there? Every island in Indonesia could have had endemic humans we haven't found yet. Homo luzonensis in the Philippines confirmed the pattern. Another tiny human, another island, another mix of primitive and derived features, discovered in 2019, dated to 50,000 years ago, the exact same time Homo floresiensis disappeared. The entire region was full of different humans, each island its own evolutionary experiment. The failure to find more sites frustrates everyone. Flores has hundreds of caves, but most are unexplored. The jungle reclaims everything. Volcanic ash buries sites. The limestone geology that creates caves also destroys bones with acidic water. We might be walking over Homo floresiensis sites daily without knowing it. The budget for continued research is insulting. Space gets billions, archaeology gets pennies. One Mars rover costs more than all hominin research ever conducted. We're spending fortunes to find life on other planets while ignoring the other humans who shared our own planet. The priorities reveal what we value, and apparently our own origins aren't valuable. The recent tool discoveries keep pushing dates back. Million-year-old tools on Flores, 700,000-year-old tools on Luzon. Someone was island hopping through Indonesia when Homo erectus was barely out of Africa. The timeline makes no sense with our current models. Either dating is wrong or everything we think about early human migration is wrong. The conferences about Homo floresiensis turn into academic warfare. Camps form around different theories. The pathology believers still exist, still arguing despite overwhelming evidence. The primitive ancestor camp fights the Homo erectus dwarfism camp. Everyone has invested careers in their position. The bones become secondary to academic politics. Meanwhile, development threatens the sites. Roads planned through fossil areas, hotels built on potential excavation sites, agricultural expansion destroying cave systems. Every year, evidence disappears under concrete and cultivation. We're racing development and losing. In 50 years, there might be nothing left to excavate. The experimental archaeology reveals how little we understand. Modern humans trying to replicate Homo floresiensis tools fail repeatedly. We can't get the same edge angles, can't achieve the same durability. Something about their technique, their hand structure, their approach made their tools work in ways ours don't. Even their failures were more successful than our attempts. The education challenge grows yearly. Textbooks can't keep up with discoveries. Museums have outdated displays. Teachers don't know what's current. Kids learn human evolution as a straight line from ape to human, when reality is a tangled bush with branches we're still discovering. Homo floresiensis should be transforming education, but bureaucracy moves slower than science. The folklore studies reveal patterns across Indonesia. Every island has small people stories. The details vary, but themes repeat. Hair-covered, long arms, strange speech, cave-dwelling, food stealing. Either every island invented the same myth independently, or they're all describing something real. The second option is scarier but increasingly plausible. Climate change threatens everything. Rising seas will flood coastal caves, increased storms will erode sites, temperature changes will accelerate decomposition. The evidence for Homo floresiensis and other endemic humans is disappearing faster than we can find it. We're trying to solve a puzzle while pieces dissolve. The technological implications extend beyond anthropology. If Homo floresiensis achieved consciousness with 400 cubic centimeters of brain, our models for artificial intelligence need revision. Maybe we're over-engineering AI the same way evolution over-engineered our brains. Maybe consciousness is simpler than we think, or maybe it's so flexible that multiple architectures can achieve it. The pharmaceutical companies show interest now. Island populations often develop unique genetic solutions to problems. Homo floresiensis survived in conditions that should have killed them. Their biochemistry might have included novel adaptations for disease resistance, longevity, efficient metabolism. But without DNA, it's all speculation. Cures might have died with them. The indigenous communities have complex feelings, pride that their islands produced unique humans, anger that outsiders control the narrative, frustration that they can't access their own heritage. The bones of Homo floresiensis became symbols of larger conflicts about ownership, identity, and colonialism in science. The creationists hate Homo floresiensis with special passion. Can't be disease if there are multiple individuals. Can't be recent if tools go back 1 million years. Can't be human if the anatomy is primitive. They tried lawsuits to prevent teaching about Homo floresiensis. Failed, but the pressure continues. Science versus faith, with tiny bones as the battlefield. The conspiracy theories multiply online. Government cover-ups hiding living populations, secret DNA evidence proving interbreeding, Homo floresiensis as aliens, time travelers, genetic experiments. The scientific community's inability to answer basic questions leaves room for any explanation. The truth is strange enough that fiction seems plausible. The next generation of researchers brings new perspectives but faces old problems. Better technology but degraded sites. More knowledge but less funding. Greater interest but increasing destruction. They're trying to salvage what previous generations missed while time runs out. The lesson of Homo floresiensis isn't about the past, it's about possibilities. They proved humans could be tiny, have small brains, use primitive anatomy, and still survive for nearly 1 million years. Every rule we thought evolution followed, they broke. If they were possible, what else is possible? What other impossible things are we wrong about? The silence they left is deafening. No art we've found, no clear burials, no monuments, just stones and bones in caves. 900,000 years of existence compressed into a few cubic meters of fossils. They lived 50 times longer than recorded human history and left barely a trace. Makes you wonder what will leave and who'll find it. The final excavations at Liangbua might be happening now. Political pressure, development demands, and funding cuts threaten to end research. We might have found all we'll ever find of Homo floresiensis. The rest of their story, if it exists, will stay buried. The smallest humans who ever lived are disappearing again, this time forever. Their legacy is questions without answers. How did they survive so long? Why did they stay small? What were they thinking? Did they have language, art, religion? Were they happy? The bones can't tell us, and nothing else remains. They proved we don't understand human evolution, then vanished before we could learn more. We know Homo floresiensis existed. We know they made tools, used fire, hunted elephants, and survived longer than any other human species. We know they were impossible until we found them. Everything else is mystery. They changed science just by existing, then left us to figure out what their existence